All right. Hi, everyone. My name is Mr. Patel. For those of you that don't know me, for those of you in the other sections that are getting to watch this video, I am one of the Algebra 9 teachers here, and this is going to be your first Algebra 9 video, COVID edition, So a couple of notes that I want to make on here. I'm writing with the mouse, so if you can't read something, please just let me know. Um, or email your teacher, and I'm sure we can figure it out. But just bear with us as we are kind of working with, you know, we're working from home, so we don't have the best technology, but we're going to make the best out of the situation. But yeah, welcome to your first video, and let's get started. So today we're going to look at 1.1. We're going to have two parts to this video, so I'm going to do the first page in the first video, and I'll put the second, make a second video for the second page. So that's kind of what the plan is here. But today, your learning targets, or what you're going to be able to learn by the end of today, hopefully, is going to be solving linear equations using basic operations, and how to use linear equations to solve some real life problems, right? So math isn't just a bunch of numbers and variables, right? We use it to make real life, to solve real life problems, which is why it's so interesting, in my opinion. So that's why it's pretty cool. So we have a couple warm-up problems here. I'm going to zoom in a little bit on this so we have more room. Okay. So warm-up problem, solve the following problems using mental math. Okay. We're going to do a couple things here. It's going to lead to some definitions. But whenever we want to solve a variable, okay, whenever we're trying to solve something, we're trying to isolate the variable. So what we're trying to do is get x alone. So we're going to try to do whatever we can to make x go alone. So now what do I notice? Well, I notice that I have this plus 2 next to the x. Get a little thicker. All right, we got plus 2 next to x. So if I'm trying to get x alone, how do I get rid of a plus 2? Well, what's the opposite of addition? Right, this is where we're going to talk about inverse operations. Well, what's the opposite of addition? The opposite of addition is subtraction. So if I subtract 2 on this side, but now what do we notice? Well, we have an equal sign in this problem. And that becomes a problem because if I can't just do something to one side of the equal sign, right? If I just left this, if I just got rid of 2 and I'm just like, okay, I'm just going to cancel these out, then I'm left with x equals 17. Which, okay, that's a solution. We got x alone. But is this the same thing as what we have over here on the left-hand side? It's not, right? So that's where we got to be careful. So whatever we do on one side of the equation, what I can do is draw a little line in here. Just different color. I can draw a line through my equal sign. Now, whatever I decide to do on one side of my equation, right? An equation stands for the equal sign. Equate is in there. Something with equal. If I do minus 2 on one side, then I've got to do minus 2 on the other side. Well, now our answer is what's 17 minus 2? And we get an answer of 15. Okay. Next problem. And I can write this as equals x. X equals 15 or 15 equals x. So number 2. Same type of problem, but instead of a minus sign, we have this line here. And again, thinking back, right, what does a fraction bar mean? This just means divide, right? I have a division. So I have x divided by 6 equals 4. Well, what's the opposite of addition? Or sorry, what's the opposite of division? It's just going to be multiplication. So here, if I want to get rid of this divided by 6, x divided by 6, what I'm going to do is multiply by 6. And if I multiply by 6 on one side, well, what do we know? Well, we got to draw a line through the equal sign. We got to multiply by 6 on the other side. And again, if you want to say this verbally, if you want to kind of work this out a little bit, you have x divided by 6 times 6. Right? So if I divide by 6 and then times by 6, these are just going to cancel out. And so now I'm just left with an x equals on the left-hand side. And then what do we have on the right-hand side? Well, we have 4 times 6, which is just 24. All right, same thing on the next problem. I'm going to put a line through my equal sign. And now I have a minus 7 here on this left-hand side. And again, I'm trying to isolate x. I'm trying to get the variable. Now, the variable doesn't always have to be x, right? I could change x and make it a z. I can make it a b. I can make it whatever I want to, whatever letter I want. But x is what's commonly used. Now, same thing. How do I get rid of a minus 7? Well, I can plus 7. And again, think about it. I have x take away 7 and then add 7 back. Aren't I just going to get what's left, which is just x, which is exactly what we want? But now if I do it on one side, I got to go through and do it on my other side. So then you can cross these out over here. And what are you left with? What are you left with? X equals 3 plus 7, which is just 10. Okay, last one of the warm-up here. We have 9x, or sorry, 2 more. We have 9x equals 54. Now, what imaginary operation is happening between this 9 and the x? Well, if you don't see an operation in math, it's going to be multiplication. So right here, this is really 9 times x equals 54. Again, whenever you don't see something, it's just a multiplication sign. Whenever you don't see an operation there. Okay. Well, again, same thing. We just got to think, well, how do we undo a times? Well, the opposite of multiplication is division. And if I divide by 9, well, here you have x times 9 divided by 9. So then you're just going to be left with x on one side. And over here, if I do it to one side, I got to do it to my other side. So 54 divided by 9. And you get x equals 6. Okay, let me scroll up here a little bit. So now, same type of problem here, but this time we just got some words in here, right? Math is just a language, so we can use math to solve real life problems. So here we go. We got Katrina divided her photos into 3 albums. Each album contains 36 photos. How many photos did Katrina have to begin with? Right, so what do we know? We know we have 3 albums, album 1, album 2, album 3. And inside of these albums, we have 26 photos. We have 26 photos, 26 in each of them. So can we come up with a way of solving how many total photos we have, right? You can think about this as 26 plus 26 plus 26, right, which is fine. But could we come up with another way? You could come up with this as 26 times 3, and that equals 78 photos. Now, one thing I want to note on this is how I labeled my answer, right? You see how I put the word photos in at the end, right? And this is just one of those things that as you become better and better math students, you want to just get used to doing, right? We want to get used to labeling our answers whenever we can, right? Just so it gives the reader, whoever's reading your answer key or whoever's reading whatever you're doing, some context as to what you're solving, okay? Just keep that in the back of your mind. Okay, so this leads to a couple of definitions here that we're going to have. So what are inverse operations? Inverse operations are just operations which are stuff like multiplication, division, addition, subtraction. There's other ones, but for right now, I'm going to focus on those. That undo each other. Right? That's the most simple definition we can have, right? They're operations that undo each other, or another way to think about it is I don't want to say they're inverses of each other just because that might confuse you guys a little bit. So I'm just going to leave it at that, right? They undo each other, right? So what are some examples of these, right? Well, if I start with the number 1, if I start with the number 1, if I add 2 to it, okay, well, what's the inverse of adding 2? If I want to get back to 1, I can just go subtraction 2. Right? 1 plus 2 minus 2 is just 1. And if you don't believe me, you can count that out if you want. Right? But here, the plus 2 and the minus 2 are going to be inverse operations. So what are the big ones that we look at in math? So we kind of talked about this already, but multiplication and division are inverses. And the other big one that we're going to talk about in this class, so that's one set, and then you have another one, which is addition and subtraction are inverses of each other. It's going to lead to one other definition here, which is equivalent equations. And again, like I said before, math is language, right? So what word do you see in equivalent equations, right? Both of them have the word equal in it. Okay, so if you think about it, maybe in middle school terms like equivalent fractions, right? It's another way of thinking about it. But these are algebraic expressions that may look different, actually produce the same answer. And a really basic example of this, right, is going to be if I have 16 on one side, is equal to, there's my equations, right? I got set equal to each other, 2 times 8. Right? These are the exact same thing, just written 2 different ways. Okay? So we're going to take a lot of time looking at equivalent equations and solving those. So that's going to be a lot of what we do. Now, the nice thing about math is what it says right here, where we can check our solution. That's the nicest thing about algebra, is you can always plug your answer back in and get the right answer and double check. So that's going to be really nice. So let's start solving some of these problems. So the first one, we have y plus 7 equals 10. All right, so I'm going to do the same thing. Now, once you get used to this, you don't have to, draw this line in anymore. But I'm going to draw this line in for now. So we have two sides, right? We can work on either side of the equation. So you have y plus 7 equals 10. So again, same thing. I'm going to try isolate the variable, whatever my variable is. In this case, my variable is y. So I'm going to try to get y alone. So what can I do? Well, I got to deal with this plus 7. I got to deal with this plus 7. Well, how do I get rid of a plus? Well, we just said above that the inverse of an addition is a subtraction. And like I said at the beginning, whatever you do on one side of the equation sign, right, it's got to be equal on both sides of the line. Okay, well, I got to do it to the other side. So if I minus 7 on one side, I got to minus 7 on the other. Well, what happens with this plus 7 and the minus 7? They cancel out, right? Because again, they are inverses. Y, and now on the other side, we're just left with a y equals. Now, what's on the right side of our equal sign? We just have 10 minus 7, which is 3. Right. Same thing on the next one. I'm going to draw a line in. Okay. So same thing, right? I've got my variable here. That's my x. I've got a number that's not a variable over here. I'm trying to get x alone. So again, same thing. Here we have a minus 5. So what's the opposite of subtraction? Well, we just said they're inverses. So addition and subtraction are inverses. Oops. Plus 5. And again, what did I say? If you do it on one side, we got to do it to the other side. So here, these cancel out. Again, a minus 5 and a plus 5, what does that equal? It's 0, so it just goes away. And so if I got an x on the left-hand side equals, well, 3 plus 5 is 8. All right, same type of deal here. Except now we got a different operation. Again, from what I said earlier, if you can't see an operation in math, right, I could rewrite this as a multiplication. This is 4 times x equals 48. Okay. Now, in math, we like to use a dot for multiplication just because if I made this like the multiplication sign x, then you have like an x and an x next to each other and it just looks kind of weird. So we're gonna try to use dots whenever we can to denote multiplication, or you could use parentheses if you're comfortable with parentheses. And then equal sign. Okay, so I haven't changed anything yet, but I've got to get rid of this multiplication by 4. Well, what's the opposite of multiplication? That is division. So I can divide by 4 on both sides. And 4 divided by 4 is just 1, right? And 1 times anything is just itself, so this is going to go away. And if you want to challenge yourself, you can think about inverse operations and the identity operation if you want to like really challenge yourself and get into the math world, and think about that and what that means, and think about what the identity of multiplication is and the identity of addition is. But that's just a challenge. Now, 48 divided by 4, right? Again, fraction bar means divided. Well, what's 48 divided by 4? That is just 12. Okay. Now, we're supposed to go back and check all of our solutions. Let's just do that real quick before we get too far. So if I take this 3, let me erase some stuff here. Okay. So if I take this 3 and I go ahead and I plug it back in to check to make sure that my answer is correct, well, what happens? Well, I get 3 plus 7 equals 10. This is a great thing you should do on your homeworks and your tests and quizzes because it's a good way to make sure you get the right answer. But what's 3 plus 7? 3 plus 7 is 10. And the last time I checked, 10 is equal to 10, right? So we have created a correct solution. Okay, I can do the same thing on the next one. I can take this 8 and plug it in right here. Right, we're saying x is equal to 8, so I can take this 8 and plug it in for x. Right, it's called substitute in. So you have 8 minus 5 equals 3. Well, what is 8 minus 5? That is just 3. And again, same thing, just 3 equal 3. Last time I checked, that's yes. So we're good on that one. Let's do another one. Again, same thing, I got a 12 here. So I'm saying x is equal to 12, so I can take this and plug it in right here. And I get 4 times 12 equals 48. Well, does 48, and 4 times 12 is 48. Does 48 equal 48? That is correct, so we're good there. Okay, so this is the best thing about algebra is you can always plug stuff back in and then find the right answer. Okay, let me clear some space here. So same deal, I'm going to put an equal sign or a line through my equal sign so I know which two halves of the problem I'm working on. And here we got the same thing, right? Now equal signs, the nice thing about equal signs is you can flip them around, right? So I could say x equals 2 and 2 equals x is the same thing, right? So you can flip equal signs around like that, which is pretty nice. So that's why you see this variable on the right-hand side compared to the left-hand side. It's the exact same thing. It doesn't make a difference. Okay. But what do we have here? We still have a -5. I could rewrite this as -5 times y, and here you have -65. And same thing, how do we get rid of a multiplication? You divide by -5. These are going to cancel out. And if I do it on one side, I got to do it to the other side, -5. Now, quick reminder on negatives, right? 2 negatives cancel each other out, right? These negatives are just going to cancel each other out. And so now you're just left with 65 divided by 5, and that is equal to 13. And again, we can verify this by taking this answer and plugging it in right here. Negative 65 equals negative 5 times 13. Negative 5 times 13 is negative 65. So we have negative 65 equals negative 65. So that is correct. All right, last set of problems on this video, and then we'll I'm going to stop this recording. So I'm going to do the same thing, same sort of setup. I'm going to go ahead and draw my equals or my line through my equal sign real quick. So there, 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 and right there. And I'm not going to check the solutions on these ones. I want you guys to go back in and check them. Now, same thing here, right? I'm looking over, I'm trying to isolate the variable, which is this t up here. And what do I notice? I've got it divided by negative 3. Well, how do you undo a divided by? I'm going to multiply by negative 3. And if I do it to one side, I got to do it to the other side. T times negative 3 divided by negative 3. Well, these are just going to cancel out nicely. And I'm just left with a t. And what's 9 times negative 3? Well, a positive times a negative is going to be a negative. Now what's 9 times 3 is 27. Okay. Same thing on the next one here. Look, we have a fraction bar. Again, fraction bar means division. So how do you undo division? Multiplication times 7. We do it to one side, I gotta do it to the other side. This divided by 7, this times 7 cancel out. Again, they're inverse operations. So I'm left with c on one side equals 7 times 6 is 42. Solution. All right, now the last two are a little trickier here because now, if you noticed, everything on the top was just our variable, right? But now we have 5/6 w. So this may be a little more confusing, like, well, what's going on here? Well, what did I tell you guys before? That what operation is happening when you can't see one in math? Okay, what operation is happening here? Right, between the 5/6 is one thing, the 5/6 is one thing, and we have our variable, which is w. Well, what operation is happening there? Well, that's just multiplication. This is the same thing. I could rewrite this as 5/6 times w equals 10. Well, how do I get rid of a times 5/6? You just divide by 5/6. Okay, these are going to cancel out. And over here, you have it divided by 5/6. Okay, now this is going to get into some really good fraction review. Let me clear some space. Okay, so we have w equals, right, we cancel out everything, so now we're left with w equals 10 divided by 5/6. Well, I can rewrite 10 as a fraction, so you have 10/1 divided by 5/6. Now, if you think back to your middle school days, how do you divide a fraction? Well, you multiply by the reciprocal. Okay, and a reciprocal is just you flip this fraction around. This is equal to 10/1 times 6/5. Now this gets a little easier because when you multiply fractions, it's pretty nice because you can just go directly across. So 10 over 6 is 60, or 10 times 6, sorry, 60. 5 times 1 is 5. What's 60 divided by 5? Well, if you look at the clock, you get W equals 12. Again, that's some good fraction review. If you need to take some time to go with fractions, it's probably a good idea. Okay, got one last problem in this video. Move over a little bit. Okay, same deal here, right? I have negative 3/4 times m, right? There's no operation here, so that's basically just a multiplication problem. So how do I get rid of a negative 3/4? I can divide by negative 3/4. If I do it to one side, I gotta do it to the other side. And my hint to you is that whenever you see it divided by a fraction, it's just to turn it into a multiplication of a reciprocal. Okay, so this negative 3/4 on the right-hand side, and this one on the bottom are going to cancel out. So that's pretty nice. So we're just left with an m. I'll do it down here. So m equals, now we have 9 divided by negative 3/4. What did we just say about dividing by a fraction? It's the same thing as multiplying by a reciprocal. So I have 9. If I want to write 9 as a fraction, I can just put it over 1. So 9 over 1 times the reciprocal of this, and reciprocal means you just flip the fraction around. 4 over negative 3. And now you're just multiplying straight across. 9 times 4 is 36. 1 times negative 3 is negative 3. Doesn't matter if you put the negative on top or bottom. You're going to see that in a second. Just going to, you only have one negative, so it's just going to turn into a negative solution. 36 divided by negative 3 is negative 12. So you have m equals negative 12. So that's the first video on 1.1. As always, if you guys have questions or anything, please feel free to email any one of the Algebra 9 teachers. We'll be more than happy to help you. So we'll see you guys in the next video. Thanks.